Hello everyone, my name is Namit Mehta and today we are doing our group project on Izod impact test. In this experiment we have to determine the strength and uh, toughness of the material with the help of the pendulum. Uh, Here we are dealing with two samples, that is brass and aluminium. Steel can be used in the manufacturing industries like car manufacturing, etc. Aluminium and brass can be used in metal industry sectors like aerospace, nuclear and automobile industries. Aluminium can also be used in the manufacture of machines and equipment. And so let's continue with our experiment with every precaution. Thank you.
Hello, my name is Bishop Umra and today we are going to do the pendulum Izod impact test with this pendulum. So we have a sample of brass. So first this is pendulum, and but first we have to block this with this one like here, and then we have to place this sample like here, and it should be level with this piece like here. So after it's here, then we have to tie it with this one. It should be perpendicular to the surface, and it should. And after that, we have to pull this up when it's first click. Then we have to release this, and we have to move this to touch this one, not to push too hard. And after that, we have to close the door. When the door is closed, then we have to pull this like here, and after that, we will release the lever, and it will done the whole thing. And after that, we have to push the brake. You have to replace that one and put this pin at one. After we done with our piece, we have to measure the angle with this protector like this. We have to place the 0 to the same to the 0, and then we have to measure the angle like from here. It's 120 like this one.
My name is Mayresh Donde. We are here to perform a group project in the Izod material testing lab, guided by Professor Hardinari. It's Izod impact test experiment. In this, we have to detect the various properties of metals. This is aluminium. This is the supporter, or what you call it as. And this is the indicator, having the needle, the lever, the pendulum. Alright, so we have to take the pendulum in forth and back in such a way that it will hold this, and the supporter will hold, and we have to adjust this piece, which is aluminium alloy or something, in such a way that it will fit with the supporter in the reverse direction, not this shorter side upside, in such a way that it will fit so I'm pulling, so you have to pull the pendulum in such a way that, and then again we have to leave it, then needle we have to press it down in this. The next step is to take this lever, small lever, put it in the second socket, second pin, and then move, take it in such a way that it will start. It is falling in.
Hi, my name is Gaganji Singh. A few minutes before we have performed the Izod impact experiment, and now I'm going to show you guys about the calculation based on this experiment.
Experiment is fully based on this diagram. Here R is the length of the pendulum arm, which is given to us, which is 0.8 meter. The A is the angle of fall, which is also given to us, which is 73.5 degree. B is the angle of rise, which is different for different samples, and W is equal to mg. Mass is given to us, which is 12.07 kg. G is the gravity, so we have to find the W. And here A is the initial height of the pendulum, and B is the pendulum arc height after the impact. In this experiment, we have to calculate different things like potential energy, impact velocity, initial height of the pendulum arc height after the impact, and EABS, which is energy absorbed by the specimen. First, we have to calculate the potential energy. The formula given to us is EP is equal to mgp, where B is the pendulum arc height after the impact. To find the pendulum arc height after the impact, we have to solve the formula, which is given to us. B is equal to R1 minus cos beta. Beta is the angle of rise, and the angle of rise recorded here for the brass sample is 71 degree. So putting all the values, we find that B is equal to 1.47 meter. Now, putting all the values of M, G and B in the EP formula, we find that the potential energy is 123.84 Newton. Now, the impact velocity. The formula is 2gh raised to power half. G is the gravity and h is same as the pendulum arc height after an impact. Putting all the values, we found the impact velocity for this experiment. Now for the initial height of the pendulum and pendulum arc height after the impact. The initial height pendulum formula is A is equal to R1 minus cos alpha. Alpha is given to us, which is 73.5 degree. So we find the value of the A is equal to 1.057 meter, and pendulum arc height after an impact B is equal to R1 minus cos beta, which is beta is angle of rise, which is recorded by us, that is 71 degree. So we find the value of beta B is equal to 1.07 meter. Now, energy absorbed by the specimen, EABS. Here the formula is WR cos beta minus cos alpha. W is the weight of the pendulum, which we can find by mg formula. M is 12.07 and G is the gravity, which is 9.8. R is the pendulum arm length, which is 0.8 meter. Cos beta is the angle of rise, and cos alpha is the alpha is the angle of fall. So putting all the values, we found the energy absorbed by the specimen value 1.109.
My name is Rohit Babur and I am here to give the conclusion for the Izod impact test. We have conducted the experiment using two samples, that is aluminium and brass. Based on the calculations, we have concluded that Aluminum absorbs the most impact energy while brass the least. The Izod impact test is used to compare the impact energy and to decide which material is best used for the following applications. As we know that we use different type of materials for different applications. The aluminum is used in packaging industry and also in shaping industry, while brass has heavy weight and it's not easily shapeable or it's not that much ductile. And aluminum gives much ductility and it's very light in weight and easily available.